Nursing 431, Inferential Statistics. The course learning outcomes include integrate knowledge from other disciplines when utilizing the research process and critically analyze research findings. The weekly learning outcomes include examine two broad classifications of statistics, discuss purposes of descriptive and inferential statistics, describe appropriate use for descriptive and inferential statistics, describe methods used to present research findings, and lastly, critique selected quantitative research articles. Two broad purposes of inferential statistics include estimating population parameters from sample data, which involves determining confidence intervals, and testing hypotheses. The time of data collection distinguishes the two purposes. The estimation of the population parameters is considered after the data are collected, whereas the testing of a hypothesis is considered before data collection. Sampling distribution of the mean approximates a normal curve when samples contain 100 or more observations or values, but samples as small as 30 are generally adequate. Whenever a large number of sample values are arranged in a frequency distribution, those values will be normally distributed, even if the original population of values was not normally distributed. The standard deviation of any sampling distribution is called the standard error. The standard deviation of the sampling distribution of the mean is called the standard error of the mean. When a theoretical sampling distribution of the mean is used to estimate a population mean, some error is likely to occur in this estimate. But the smaller the standard error of the mean, the more likely the sample is an accurate reflection of the population mean. The central limit theorem is the phenomenon in which sample values tend to be normally distributed around the population value. A sampling distribution is a theoretical frequency distribution based on an infinite number of samples. A confidence interval, or CI, is a range of values within the population parameter which the population parameter is thought to occur. This range contains a lower and upper limit that, with a specified degree of probability, is thought to contain the population value. A hypothesis should be based on the theoretical or conceptual framework of a study. The hypothesis generally should be directional research hypothesis that predicts the results of a study. A null hypothesis states that no differences exist between the populations from which the samples were chosen, or no correlation exists between variables in the population. The null hypothesis is the one that is subjected to statistical analysis. Null hypotheses are rejected or retained depending if a correlation can be determined or if the difference is due to chance. Research hypotheses are supported or not supported, but one cannot reject a research hypothesis because it is never tested. The level of significance can be defined as the probability of rejecting a null hypothesis when it is true, and it should not be rejected. The letter P and the Greek letter A, the Greek letter alpha, which is the small lowercase a, are used to symbolize the probability level that is set. The most common level of significance that is found in nursing studies is P, which equals 0.05. A critical value denotes that the value in a theoretical distribution at which all obtained sample values that are equal to or beyond that point in the distribution are said to be statistically significant. All values beyond the critical value are said to lie in the critical region or region of rejection. Degrees of freedom concern the number of values that are free to vary, but the concern is really focused on the number of values that are not free to vary. The interpretation of statistical tests is dependent on the degrees of freedom. Research hypothesis may be stated in a directional form, which is the degree of difference or type of correlation that is predicted, or in a non-directional form, which is a difference or correlation is predicted, but the degree of difference or type of correlation is not indicated. If the researcher has stated directional research hypothesis, it is appropriate to use a one-tailed test of significance. One-tailed tests seek differences or correlations in only one tail of the theoretical sampling distribution. A non-directional research hypothesis calls for a two-tailed statistical test and determines significant values in both ends of the sampling distribution. It is easier to reject the null hypothesis with the one-tailed test than the two-tailed test. A type 1 error occurs if the null hypothesis is actually true and it is rejected by the researcher. A type 2 error occurs if the null hypothesis is actually false and the researcher fails to reject it. As the probability of a type 1 error increases, the probability of type 2 error decreases and vice versa. Type 1 errors in research findings usually result in unnecessary changes being instituted, whereas type 2 errors result in failure to institute needed changes. Now on to parametric tests and nonparametric tests. Parametric tests are concerned with population parameters and make assumptions about the population from which the sample was drawn. The assumptions of parametric tests include the level of measurement of data is interval or ratio, data are taken from populations that are normally distributed on the variable that is being measured, and data are taken from populations that have equal variances on the variable that is being measured. Non-parametric tests or distribution-free statistics are less stringent in the requirements for their use and do not make assumptions about the population from which the sample is selected. These tests may be used with nominal and ordinal data, and sample sizes may be small. The power of a statistical test is defined as the ability of a test to reject a null hypothesis when it is false. The power of a statistical test is dependent on the sample size and the level of significance that is chosen. The larger the sample that is chosen, the more power the statistical test will have. The higher level of significance that is selected, the more power the statistical will have. A test will also be more powerful if a one-tailed test rather than a two-tailed test is used. If the assumptions of parametric tests are met, these types of statistical tests are more powerful than non-parametric tests. A t-test compares the difference between the mean values of some variable in two groups of interval or ratio data. It is appropriate for samples of nearly any size, but it is particularly useful with small sample sizes fewer than 30. Also, because this t-test is a parametric test, the sample data are assumed to have been selected from populations that are normally distributed and have equal variances on the variable that is being measured. Analysis of variance, or ANOVA, is a parametric statistical test and therefore is based on the assumption that data are interval or ratio level and that data have been selected from populations that are normally distributed and have equal variances on the variable that is being measured. It is appropriate whenever the researcher wishes to compare the difference among more than two means. ANOVA allows the researcher to simultaneously analyze the difference among several means at one time. The chi-square test is a non-parametric inferential technique that is appropriate for comparing sets of data that are in the form of frequencies or percentages. The chi-square statistics, X2, is probably the most commonly used statistic with nominal data. Minimal understanding of inferential statistics is sufficient for the reader to understand the majority of the study results. The reader should search the report for any inferential statistics that were used in data analysis and determine if there is enough information to make a decision about the appropriateness of each test that was used. The reader should be provided with the value of the statistical test that was obtained, the degrees of freedom, the significance level that was reached when each hypothesis was tested. The reader should be able to determine if each of the researcher's hypothesis was or was not supported. Every research report should clearly present the results of hypothesis testing in both the text of the report and in tables.